You've heard the slogans, 5G, built right. 5G just got real. America's first smart network. Those 5G ads make big promises. But it's interesting that they're targeted mostly to consumers, because it's the enterprise, really, that stands to reap the biggest rewards from this technology. That's why it's essential for organizations to understand the benefits and challenges of 5G, because it brings some compelling capabilities that enterprises should evaluate for their networks. In the next few minutes, we'll cover how 5G technology works, some use cases, plus the benefits and challenges, so your business can understand 5G more fully. For a deeper dive, explore our complete collection on all things 5G by clicking the link above or in the description below. 5G stands for fifth generation. That is the fifth generation of cellular communications technology. The third generation partnership project, or 3GPP for short, initially released 5G in 2017 after years of development. 5G greatly increases the capacity and versatility of wireless connectivity, with potential speeds of 20 gigabits per second and very low latency. It's also engineered to be much more secure than its predecessors. So how does it work? 5G sends data using radio waves and frequency bands, such as millimeter wave and midband. 5G uses a vast network of cell towers and small base stations, called small cells, to transmit signals. About the size of a pizza box, these small cells can also be located on places like light poles and building roofs. 5G is designed to primarily use high-frequency millimeter waves, which are shorter frequency waves than those used in previous cellular technology. Millimeter waves are ideal for high-speed communications because they minimize latency, but they can only travel short distances and are susceptible to weather and physical obstacles. They work best in densely populated areas or open venues like factories and stadiums. 5G can also use lower frequency bands, such as low band and midband, which have greater reach and penetration than millimeter waves. The trade-off with these lower frequency bands is they support fewer devices at potentially lower speeds and greater latency. That's why many enterprises concentrate their 5G efforts on locations that can take optimal advantage of 5G's capabilities. When it comes to 5G infrastructure, two main options are available: standalone 5G and non-standalone 5G. Standalone 5G is the truest form of 5G, built on 5G core networks and 5G radios. Non-standalone 5G provides a bridge between legacy 4G LTE infrastructure and true 5G, using 4G core networks and a 5G radio access network. Most 5G deployments at this point use non-standalone 5G, as carriers gradually build out their more expensive standalone 5G networks. 3GPP continues to develop 5G standards, such as 5G New Radio, or 5G NR, which would replace LTE. 5G NR supports the growth of wireless communication by enhancing spectrum efficiency. So pay close attention to 3GPP's work. 5G offers an array of business benefits. The higher speed and lower latency of 5G enable it to support automation in branch offices. 5G is also less costly and more flexible than MPLS and other dedicated lines often used for latency-sensitive applications. And because it has higher capacity, 5G supports more users and devices connected in the same physical area without affecting availability. Then there's the power savings. 5G can cut power consumption on devices by up to 90%, which is beneficial for IoT environments. 5G has additional security features that make it a more trusted option than 4G for IoT, branch, and other enterprise traffic. One example is the fact that 5G uses 256-bit encryption in contrast to 4G's 128-bit standard. 5G architecture better supports machine-to-machine communication than its predecessors because it can transmit large data streams, support real-time decision-making, and foster automation. 5G's programmability also makes it easier to connect with more data sources, including resources stored in the cloud. Finally, 5G is backward compatible with other wireless technologies, including 3G, 4G, and Wi-Fi, enabling enterprises to aggregate the standard with other communication systems. 5G networks can either be public or private. To better secure their operations, many large enterprises build private 5G networks instead of procuring network capacity from 5G providers. While private networks can be more costly, they enable enterprises to customize their 5G build-outs to meet application requirements, more finely manage infrastructure, and secure data on premises. When deciding whether to build a private 5G network or buy public 5G from a provider, ask and answer some key questions. Do you need ubiquitous coverage for devices or a new type of wireless backhaul? Private 5G can provide more extensive and dedicated coverage across enterprise locations. Are you willing to trade larger cells and more reliable frequencies for millimeter wave speeds that might not meet expectations? Enterprises might want to stick with lower frequencies in their private 5G networks to prioritize reliability and low latency instead of high speeds. Some use cases, though, benefit from the fast but limited capabilities of millimeter wave. Will most of your traffic stay within the enterprise network or head out to the internet? Private 5G can be beneficial for enterprises that need to bolster security for data traffic that remains within the local network. What device types, capabilities, and density will be involved? Enterprises that use IoT sensors, robotics, and machine-to-machine communication could benefit more from private 5G. Typically, a private 5G network design includes small cell hardware and upstream connectivity to the LAN. But private 5G networks are not one size fits all. The number of use cases for enterprise 5G is expanding rapidly. Let's look at some ways 5G might improve a variety of industries. In retail, 5G fixed wireless can replace broadband connections, which enables faster connectivity and more flexible management. Retail companies could use 5G with software-defined WAN to provision and manage hundreds of locations. In healthcare, the healthcare sector is now using technology to make greater use of limited resources. For example, 5G's low latency helps surgeons operate remotely via robotic applications. Hospitals also use 5G to transmit critical diagnostic data and images that can be shared among the ER, ambulance, and field teams to provide faster and more comprehensive care. In sports, organizations like the NFL, MLB, and NASCAR have deployed 5G to enrich the fan experience through real-time access to video highlights, like instant replay. In manufacturing companies can use 5G to speed connectivity from IoT sensors on machines to the cloud for more complex real-time analytics. So, extracted insights can be used for real-time decision-making that could improve operations on the factory floor. Autonomous vehicles, which use AI along with machine learning and analytics to process information in real time, can communicate through 5G to automatically adjust speeds due to road conditions or increased traffic. And finally, city management. 5G is a boon when it comes to smart cities and autonomous vehicles. Again, the low latency, capacity, and throughput of 5G make it a prime candidate for innovation in city management and transportation. Streetlights, traffic signals, and other public safety applications can benefit from the wireless technology because 5G enables changes in patterns based on real-time events or AI models. For all of 5G's benefits, there are some challenges that enterprises should consider before moving away from legacy wireless and wired infrastructure. First up are network security concerns. The fact that 5G can simultaneously support more connected users and devices than previous cellular technology results in greater exposure to risk, which means teams must carefully assess and monitor their environments. Also, 5G requires more infrastructure that must be protected from threats. And the 5G standard itself doesn't support end-to-end encryption, and that gap early in the connection process can potentially open enterprises to attack. Then there's staffing and training. Like with any evolving technology, finding qualified IT staff to integrate 5G will be a challenge for most enterprises. IT staff need specific skills to oversee a network that shifts between wired and wireless connectivity like 5G does. Personnel must also be able to troubleshoot 5G technical issues and manage 5G-enabled network components, ranging from simple IoT sensors to complicated machinery. Another challenge is cost. 5G requires a hefty investment to reap its full reward. Legacy network components have to be swapped out with those that are 5G compatible. Companies also have to buy new wireless gear to ensure adequate coverage. Then there's the issue of signal interference. Perhaps more than any other wireless technology, 5G requires network teams to pay close attention to site surveys. A site survey can reveal the extent of signal penetration challenges, like walls or specially coated windows, and radio dead spots. A site survey also shows how hard it will be to mitigate things that interfere with the 5G signal, such as facility redesigns or antennas. And finally, there's the basic challenge of 5G availability. Companies that want to take full advantage of enterprise-wide 5G must first determine whether the cellular technology has been launched at all of their locations. After all, service providers are still in the process of rolling out their 5G services, with most of their attention focused on densely populated areas, such as major metropolitan cities. Let's say those challenges seem manageable to you and your enterprise. What's next? First, chart a roadmap for when enterprise equipment and applications will be available to your business to support 5G. 5G service is only as good as the devices and applications using it. Next, create a timeline for procuring 5G services. That means deciding whether to lease, buy, or build a 5G network. For example, enterprises could buy public 5G services from a mobile operator, lease a 5G network slice, or build a private 5G network. Enterprises that want to build their 5G network should partner with an integrator, vendor, or service provider to help with the more nuanced aspects of 5G. There are 4 key factors to consider when building a private 5G network. 1. Spectrum for the radio network. 2. 5G infrastructure to provide the required features and interfaces. 3. Small cells or microcells to transmit and receive. And 4. Interconnected facilities to link the private 5G network to the public mobile network if required. New iterations of 5G are waiting in the wings. The 5G Advanced Standard is pegged for release in 2024, according to a timetable released by the 3GPP. 5G Advanced will support things like extended reality communications, which builds on existing augmented reality and virtual reality applications. At the same time, the wireless industry is starting early development on the 6G standard, which is expected to be released in 2030. 6G is expected to support data rates of 1 terabyte per second and also build on 5G's capabilities such as imaging, presence technology, and location awareness. But don't get too caught up in the 6G hype yet. Remember that carriers are still building out their standalone 5G networks. Enterprise 5G is all about innovation in applications. What comes next depends on how effectively enterprises take advantage of 5G's speed, low latency, and capacity to push AI, machine learning, real-time analytics, and other advancements deeper into their operations.